Imagine you buy this highly complex piece of machinery, like, say, one of those ridiculously expensive professional-grade stainless steel espresso machines.
Oh, yeah. The ones that look like a spaceship.
Exactly. And the factory manual gives you the absolute 100% perfect way to use it. I mean, it dictates the exact water temperature down to the decimal, the precise humidity for storing your beans, the optimal atmospheric pressure.
Right. It's a completely controlled environment.
Yeah, it's clean, it's binary. And, if you follow the rules in a vacuum, you get the perfect shot of espresso, but then you bring that machine into your actual messy kitchen.
Which is never a vacuum.
No.
Ah,
The dog is barking, you're running late for work, the outlets are in a totally weird spot, and suddenly you are pulling that espresso shot in a completely improvised way just to survive the morning.
you're just trying to get the caffeine at that point.
Yeah, right. And honestly, how our brains process and retain information is basically that exact scenario. I mean, we constantly look for this idealized factory manual for learning, but we operate in the messy kitchen of the real world.
We really do. I mean, we
Yeah.
tend to isolate a biological process and just, look at it under a microscope, completely ignoring the actual environmental reality we exist in when we try to apply that process.
Which is exactly why we're doing this, because whether you are prepping for a massive presentation at work or trying to survive a brutal college semester, or you're just intensely curious about how to optimize your own mental bandwidth, we are tackling a debate today that has divided dorm rooms and office spaces for decades.
It's a huge one.
Oh, yeah. Today's mission is figuring out if it is biologically, psychologically, and practically better to do your heavy cognitive lifting during the day or at night.
And it's an area where people defend their personal habits with just a lot of ferocity,
Yeah.
usually based entirely on their own anecdotal experiences rather than what is mechanically happening in their heads.
Right. It's always like, well, I studied at 2 a.m. once and got an A, so that's the rule. Which is why we're completely stripping the anecdotes away today. Our grounding material for this deep dive is a fantastic transcript from a debate show called The Study Show.
Great show.
Really great. And they pitted daytime studying directly against nighttime studying, backed by this massive stack of research from Harvard, the NIH, Stanford, and UCLA Health. So we are looking past personal preference into the raw biology of attention, the mechanics of memory, and how different types of work require, different cognitive environments. So, okay.
Aye.
Let's unpack this, starting with the sheer biological advantage of the daytime.
Yeah, because the foundational biology here relies on the circadian rhythm.
Yeah.
I mean, to decode your own optimal learning rhythm, you have to look at the body's internal 24-hour clock.
Right.
We are fundamentally diurnal creatures. Evolution basically hardwired us to be alert and processing data when the sun is actually up.
And the sources go really deep into this. Like, it's not just that daylight makes us feel nice, It's a literal physiological trigger. Sunlight actually dictates cognitive performance.
It does. It's a highly specific chain reaction. So when natural sunlight hits the photoreceptors in your eyes, it sends a direct signal to this tiny, tiny region in your brain called the suprachiasmatic nucleus.
The suprachiasmatic nucleus, that's a mouthful.
It is, yeah. But it basically functions as your body's master clock.
Yeah.
So it immediately tells the pineal gland to just halt the production of melatonin, which, as we know, is the hormone that makes you feel sleepy.
Right, the sleep hormone.
Exactly. And at the exact same time, it triggers a spike in cortisol.
And that's interesting because usually we associate cortisol with stress, right? Like, oh, my cortisol is so high right now.
Totally. But in this specific morning context, a healthy cortisol awakening response is actually what provides clarity, focus, and drive.
So your brain essentially just gets bathed in this neurochemical cocktail that says, hey, we are awake, the environment is visible, let's absorb some new information.
Exactly. You are aligning your heaviest mental effort with your body's natural physiological peak. So the whole argument for daylight studying is that you are swimming with the biological current instead of fighting against it.
Which makes sense. I mean, in a vacuum, a sun-kissed, cortisol-fueled morning brain sounds literally unbeatable.
It does.
But, and this brings us right back to the messy kitchen studying or doing deep intellectual work during the day, often feels like trying to read a dense technical manual while sitting in the middle of a busy intersection.
Right, because of the environmental reality of the daytime.
Exactly. Think about what a typical Tuesday afternoon actually looks like for you. Is the biological advantage of sunlight totally canceled out by the relentless pinging of group chats, incoming emails, your boss asking for a quick favor, and just the general noise of other humans being awake? The daytime is incredibly loud.
It's so loud. And what's fascinating here is that the psychological research from the nighttime side of our source material focuses heavily on exactly this. It explores this concept of attentional residue.
Attentional residue. So wait, like when my phone buzzes and I glance at a text and I feel like I physically lose my place in my head, what is practically happening to my mental energy right there?
Okay, so when you shift your focus from a complex task like reading a deep study or writing code to a totally different stimulus, like a text message, your brain doesn't just instantly snap back to the original task when you put your phone down.
It feels like it does, or at least we want it to.
Right, but it doesn't. A portion of your cognitive capacity actually remains stuck thinking about that text message. That is the residue. And it can take your brain upwards of 20 minutes to fully clear that residue and return to a state of deep, uninterrupted focus.
20 minutes. Wow. So you're literally burning mental energy just trying to get back to the baseline you were at before the interruption.
Exactly. Your prefrontal cortex is literally burning extra glucose just to reorient your attention. So if you are constantly interrupted during the day, you are in a perpetual state of cognitive starting and stopping.
Just constantly idling and revving the engine.
Yes. And this is where the argument for the night becomes incredibly compelling. Because as the sun goes down, the businesses close, the emails stop, the social obligations basically evaporate.
Everybody else goes to sleep.
Right. And for a lot of people, the hushed stillness of, say, 11 p.m. isn't just a preference. It is a required environmental boundary to prevent that attentional residue. You replace that chaotic intersection with an empty, quiet room.
So the night is quieter, and you can actually hear yourself think. I get that. But if you're staying up until 3 a.m. enjoying all that peace and quiet, aren't you kind of sabotaging the exact biological mechanism your brain uses to actually keep the information? Because the Harvard and NIH sources in our stack draw a very hard line here.
They absolutely do. Because sleep is not a passive state of rest, right?
Yeah.
It is a highly active neurological event. It is the primary mechanism for memory consolidation.
Right. So if we look at the daytime advocates' argument against late-night studying, it really comes down to the risk of the all-nighter. The whole idea is that studying in the morning gives you the whole day to casually process the material, and then you get a full, normal night of sleep to lock it all in.
Which is crucial.
Yeah. Because if you study at 2 a.m. and only sleep for like 3 hours before an exam, you are essentially hitting shut down on your computer without hitting save on your document.
That's a great way to put it.
Yeah.
And the mechanics of that save function are just fascinating. Because when you learn something new, that information is initially stored in the hippocampus, which acts almost exactly like a temporary USB drive.
Okay, a USB drive.
Yeah, it's fast at recording, but its capacity is fairly limited, and the memories stored there are incredibly fragile.
Huh.
During sleep, and specifically during slow-wave deep sleep, the brain transfers that data from the hippocampus to the neocortex, which is like the brain's permanent hard drive.
So it's actively uploading the files while you're asleep?
Exactly. And then later, during REM sleep, the brain actively builds and prunes the neural connections, linking that new data to things you already know.
Right, connecting the dots.
Yeah. So if you truncate your sleep by staying up too late studying, you essentially pull the USB drive out before the file transfer is complete. The data is simply lost.
Man. But here's where it gets really interesting, though. Because the sources advocating for the night, they don't deny that sleep is the ultimate save button. Not at all.
No, they actually lean into it.
Exactly. They use the mechanics of the hippocampus to defend studying right before bed. They frame it as a direct download.
Yes, leveraging a concept called retroactive interference.
Right. So the concept is that your hippocampus is just constantly recording. If you study at 9 a.m., your brain has to hold on to that really fragile data for the next, 14 hours?
Give or take, yeah.
And over the course of the day, you listen to a podcast, you have conversations with coworkers, you read the news, you watch a video. All of those new inputs create interference. potentially overwriting or confusing the data you worked so hard to learn that morning.
Because that USB drive is getting cluttered with all these new random files before it has a chance to upload to the hard drive at night.
Exactly. But if you study complex material at midnight and immediately go to sleep, you are putting a direct download into the brain right before it enters save mode. 0 daytime conversations, 0 new podcasts. The path from the input of information to the consolidation of that information is completely uninterrupted.
You are minimizing all the variables. And if we connect this to the bigger picture,
Yeah.
you essentially have 2 valid methods here, right?
Mm.
You have priming a rested morning brain for long-term day processing versus leveraging that pre-sleep study session
Yeah.
to immediately lock in facts without daytime interference. And actually, the Stanford research in our stack adds another really cool layer to this nighttime strategy. It highlights a biological phenomenon known as the evening ramp-up, or the wake maintenance zone.
The evening ramp up. Wait, is that weird second wind you get around 9 or 10 p.m.? Like you feel exhausted right after dinner and then suddenly you are completely wired and ready to organize your entire life.
That's the exact one. It's actually a well-documented part of the two-process model of sleep. So basically, throughout the day, a chemical called adenosine builds up in your brain, and that creates sleep pressure.
Okay, so adenosine makes you tired.
Right. But your circadian rhythm is actively pushing back against that pressure all day to keep you awake. For many people, a few hours before their natural bedtime, that circadian arousal signal hits a secondary peak just to fight off the accumulated sleep pressure.
Oh, wow. So it's like a final surge of cognitive energy before the melatonin really kicks in and shuts it down.
Exactly.
Yeah.
It creates this window of really intense focus and creativity that functions completely independently of the morning sunlight effect we discussed earlier.
That is wild. So we basically have 2 highly valid biological paths here. Sunlight and morning cortisol prime you for alertness, but the lack of retroactive interference and that evening ramp-up offer a massive advantage for memory retention.
Yeah, biology pretty much gives us a tie here.
Which is frustrating. Biology gives us a tie, so how do we actually make a practical decision?
Well, the deciding factor actually shifts away from pure biology and toward the nature of the task itself. The type of work you are doing dictates the cognitive environment you need.
Okay, this stood out to me in the sources. The daytime argument highlights the absolute necessity of social learning and feedback loops. Like if you are first trying to grasp a broad conceptual framework or you are doing collaborative project work, daytime is practically mandatory.
Oh, definitely. You need other people.
Right. You can text a colleague and get an instant reply. You can grab coffee with a mentor. You have bouncing boards.
And bouncing ideas off others actively triggers dopamine pathways that reinforce learning. I mean,
Yeah.
you just cannot replicate that dynamic collaborative energy at 3 a.m. If you text your mentor at 3 a.m., you're going to be annoyed, not helpful.
Exactly. But, and this is a big, but not all work requires a bouncing board. The counterargument is that if you are doing highly advanced mathematics, complex coding, or writing a deeply analytical document, you don't want collaboration.
No, you want everyone to leave you alone.
Yes, you need solitary, intensive focus. You have to hold this massive amount of fragile information in your head all at once. It's basically like computer RAM.
Right, working memory capacity.
Yes, your working memory is exactly like RAM. So you are holding, say, the structure of the essay, the 3 different sources you're citing, and the highly specific phrasing you want to use all simultaneously.
It's a heavy cognitive load.
Huge. And if a colleague pops into your office just to ask a quick question, it's like opening a massive application on a computer that's already running at 99% capacity. The RAM just crashes.
The entire mental house of cards totally collapses, and you have to rebuild it from scratch.
So what does this all mean? Does this mean we are supposed to rigidly fracture our lives based on the task? Like, do all the group brainstorming at 10 a.m. and then retreat into complete isolation at midnight to write the code?
Well, attempting to split your life that aggressively completely ignores a massive biological variable that the UCLA Health Reference dives into, which is chronotypes.
Ah, chronotypes, the genetic hardwiring of early birds and night owls.
Yes, and we all know the basic concept of chronotypes, sure. But what's critical here is understanding that it isn't just a personality quirk or like a habit you formed in college because you stayed up late playing video games.
Right.
It's a biological reality.
Right.
It's often dictated by variations in specific genes, like the PER3 gene. So your chronotype actually dictates the natural timing of your core body temperature fluctuations, your melatonin release, and your peak cognitive windows.
So we aren't just casually choosing when to work. Our DNA is actually casting a very strong vote.
Ooh, a very strong vote. and the data reveals the physical damage of ignoring that vote. The phenomenon is actually called social jet lag.
Social jet lag. That sounds awful, like the exhaustion of traveling across time zones, but without ever leaving your house.
That's exactly what it is, because you are living in a time zone that simply doesn't match your biology. The modern professional and academic world operates heavily on a 9-to-5 schedule.
Right.
Now, for a natural early bird, this is great. Their biological clock is perfectly synced with society's clock. It reduces friction, it reduces stress.
But for a genetic night owl, forcing them to do high-level cognitive work at 8 a.m. isn't just unpleasant, it actually creates measurable physiological strain.
Measurable strain. Their cortisol levels spike abnormally, their working memory capacity is physically diminished, and their metabolic health can actually suffer over time. I mean, the sources make it clear. It is just as biologically damaging to force a natural night owl to take a complex exam at 8 a.m. as it would be to force a natural morning person to do it at 3 a.m.
Wow, you are literally fighting your own physiological infrastructure. But, I mean, this leaves us walking a very difficult tightrope, because the world is structured for early birds.
It absolutely is.
If you align your study habits with the daytime, you aren't fighting the opening hours of the library or the times your manager expects you to be online on Slack. There's a massive mental health benefit to finishing your heavy lifting by 5 p.m. and actually having your evening free to just, decompress.
Right. It's the path of least resistance, socially speaking. But this raises an important question, right? We have to look at the reality of modern learners and modern workers. Flexibility is often a necessity. It's not a luxury.
Exactly. Think about you, the listener, right now. Maybe you aren't a full-time student whose only job is to sit in a quad and read all day. Think about the person working a full-time job who is actively trying to upskill at night. Or think about parents. Parents who literally do not have a quiet house until their kids are finally asleep.
Right. For them, the night isn't just a biological preference.
No, it is the only window of opportunity available where they have absolute control over their environment.
They are basically forced to utilize the night to escape the attentional residue of their daytime responsibilities.
Which brings us to the ultimate takeaway here. We set out to definitively settle the debate between day and night studying, and ironically, the research settles it by proving that the idealized factory manual simply doesn't exist. There is no universally superior time to process information.
There isn't. The optimal time is highly specific to your unique biological hardware and your specific environmental constraints.
So, optimizing your brain's performance requires an honest self-audit. You have to figure out your own peak concentration hours. If you naturally wake up energized, leverage that morning cortisol and sunlight.
Totally.
But if you consistently experience that evening ramp up and you need the quiet to protect your mental RAM from crashing, leverage the night. The goal is to identify those hours, ruthlessly defend them from distractions, and above all else, protect your sleep so the biological save button actually functions.
Right. And if you are going to use the nighttime direct download strategy, you have to do it intentionally.
What do you mean by intentionally?
I mean, study right before sleep to deliberately prevent retroactive interference, rather than just staying up late simply because you procrastinated watching YouTube during the day.
Oh, guilty.
Right. But the intentionality is what actually changes the neurological outcome.
That makes total sense. It's about working with the messy kitchen you actually have rather than the vacuum you wish you had. So, as we wrap up this deep dive into the sources, I want to pivot to the macro view. Looking at the reality of working memory, the mechanics of sleep, and the undeniable genetics of chronotypes. What is the lingering question you're left with?
Honestly, looking at the sheer biological weight of chronotypes, I keep coming back to how we universally structure education.
Okay, say more about that.
Well, if our biological peak concentration hours are deeply genetic, right?
Right.
And we know for a fact that forcing a night owl into an early schedule causes cognitive decline and social jet lag, is the traditional 8 a.m. to 3 p.m. school and university system structurally disadvantaging half the population before they even sit down to take a test.
Oh, wow. That completely changes the framing, because are we accurately measuring a student's intelligence, or are we just measuring how well their specific DNA aligns with a 19th century industrial schedule?
Yeah, exactly. It's something to really think about.
That is a phenomenal question to leave on. Thank you for joining us on this deep dive. Ignore the factory manual. Figure out how your own brain actually operates, protect your sleep, and brew your perfect shot however it works for you. Keep questioning the defaults, and we'll see you next time.